So the idea of a current shunt is to put a resistor in series with a circuit of low enough resistance to not affect the circuit, but you still remain able to measure the voltage across it. So I have a 200 watt resistor wound all the way down, so I have only 1 ohm on it, which is still incredibly high for what I need, but 1 ohm makes it easy to do the calculations on the fly. And then what I'm doing is I'm making a shunt over the secondary side of this CT. Now this CT has a ratio of 2,500 to 1. I've put 4 turns through it, making it a 625 to 1 CT. Now I'm going to generate current through the primary side using the resistor over there. Now that is set to some sort of resistance. I never worried about measuring it, but I believe it's there. So to generate the current, I'm using a Variac. So once I turn this Variac on, I can, there you go, I've got it set already up a bit. So if I've got 1.14 roughly amps on the primary side of that CT, now on the secondary side I'm measuring it on this key flea. It's a bit hard to see, but that's 1.61 millivolts. Now 1.61 millivolts times 625 gives you 1.000625 amps. Now I'm a little bit out, but I would take into account that the extra burden I'm putting on by having a such high 1 ohm resistor on the secondary side of that CT would be considerably overburdening it. So you're going to get quite a bit of an error on that. So the reason why I chose a 1 ohm resistor to put in the place for easier calculation is because the current equals the voltage over the resistance. Now given that I've got 625 turns, I can take the voltage as the current, because 0.00161 divided by 1 is just going to be 0.161. It's going to be the same. So if I just take 0.0061 times 625, I get the answer. .0625 amps. Simples.